In this video, we're going to take a look at evaluating limits at infinity. And the expression looks like this. The limit as x approaches infinity of a specific function, the result of that is going to be the y value that the function is approaching. Okay, so we're going to take a look at an algebraic method, some algebraic methods. We're going to take a look at even just a conceptual understanding of what this means. So just as a little introduction here, you may or may not have already worked through this. This is our main topic of today, limits as x approaches infinity. But there's a pretty good connection between the two. So notice x approaches 0. Notice in the table here how our x values are approaching 0. We're starting out just with 1,000. I just made these numbers up. And these numbers are getting smaller and smaller and smaller, but they don't, notice they don't go into the negatives even. They're just getting closer to 0. This number here, 1/1,000,000th, is very, very close to 0. So we're approaching that value. So as I plug these numbers in and look at the y value that results, 1/1,000, well, that's 1/1,000th. And then we have 1/10th. So that was close to 0. This is less close to 0. If I plug in a 1/1, that's 1. Now if I plug in 1 divided by 1/40th, I get 40. Notice these numbers are moving away from 0 and getting bigger. Okay? And if I put in 1 divided by 1/1,000,000th, I get 1,000,000. So we can see here, as the numbers approach 0, as these numbers are approaching 0, these numbers are getting bigger and bigger and bigger. These numbers are approaching infinity. So the closer we get this to 0, the closer our answers here get to infinity. All right, so this is our concentration of the day, but there's a pretty good connection here. So notice I'm going to fill these in. 1/1. Notice that my x values, x approaches infinity. Notice these x values are getting big. They are approaching, I might as well throw another one in here. Let's put in 1,000,000. Put in a 2 there, the limit is 1/2. Put a 10 there, it's 1/10th. Notice these numbers are getting closer to a specific value. Okay, and as we keep putting in bigger and bigger numbers here, positive numbers here, our answers are going to approach and get closer and closer and closer to 0. So as x approaches infinity, the limit is 0. And this right here is the whole idea algebraically of what we'll talk about. All right, so let's just take a look at our first example here. Let me just show you a graph of this here too. We'll look at a conceptual understanding. So we're going to take a look at both the limit as x approaches infinity, and we're going to look at negative infinity as well. So look at what this graph looks like. Okay, so most functions, not all functions, but most functions, right around 0 usually, or the origin, or a specific centered value, it can kind of do some crazy things. But we're going positive infinity way far to the right, and we're looking at negative infinity way far to the left. So usually functions, I'm going to cover this up, end up kind of being boring as you move towards infinity or negative infinity. They're either going to kind of level out and approach a specific y value, notice here and here, or sometimes they'll just keep going up forever and the limit would be infinity, or they're going to keep going down forever and the limit there would be negative infinity. So we'll take a look at a few examples here. So another thing to think about is as these numbers get bigger and bigger and bigger, and this is a conceptual understanding here, the degree, the highest degree, meaning the highest exponents, have the biggest impact or the most influence on a problem. So we're going to find, when we work through this algebraically, that we can almost ignore all this other stuff in here. Let me just show you here. Algebraically, what we're going to do is divide both the numerator and denominator by whatever the highest degree is in the denominator, and I see a second degree expression here. So I'm going to take the numerator and divide it by x squared, and I'm going to take the denominator and divide it by x squared. I'm allowed to do this with an expression because this value is just 1 here. So here's what I'm seeing now. The limit as x approaches infinity. I'm going to distribute this all through the numerator. So I have 1 over x squared minus, distribute that here, 1 over x, distribute that there, minus 1. And in the denominator, distribute that here and here, and we get 2 minus 7 over x squared. So here's this concept coming into play a few times in this problem. The limit as x approaches infinity of 1 over x, or even 1 over x squared, is going to result in an answer of 0. So down here, as I evaluate this limit now, that's going to approach 0. That's going to approach 0. So on the top we have negative 1. And then down here, that's going to approach 0. So in the denominator, we have 2, and our result is negative 1/2. Let's take a look at the limit as x approaches negative infinity of that same expression. Another thing you can do is, now that we know that the highest degree has the biggest influence, also think about the sign of your answer, meaning that is it going to be positive or negative? That's going to come in important here in a little bit. So we can basically ignore these because that's the highest degree in the numerator. So that says negative x squared. So no matter what I plug in for x and square it, then make it negative, this is going to be a negative in the top no matter what. And down here, no matter what value I plug in for x and then square it and multiply it by 2, this is always going to be a positive answer. So my answer here is always going to be a negative divided by a positive, resulting in a negative. And so the same thing happens on this side. Same algebra work, same answer. It doesn't always work out that way. So notice the graph here again. This is that function that we just found the limit for. Notice right around here, there's some crazy stuff happening, okay? But we're not talking about what's happening in here. We're talking about as x gets bigger and bigger and bigger towards infinity. So look, right here is this negative 1/2. So look, as x gets bigger and bigger and bigger, and so do you see that this function is moving closer and closer to that negative 1/2 value? That's why the answer is negative 1/2. And notice over here, this one loops up and around, but here's this negative 1/2. Okay, so this function, as it moves towards negative infinity, is also approaching that same y value, negative 1/2. All right, let's take a look at a couple more here. Okay, here's our next limit. And let me show you what that function looks like. Again, it's not too crazy. It's doing its thing in here. But notice if I cover this up, kind of boring. What's happening over here? It's zeroing in on some function value, some y value. And the same thing over on this side. All right. So I see the highest degree. You might be fooled by this at first. You might want to say it's a second degree, but we're taking the square root of a second degree expression, which is going to, again, be first degree. So I'm going to divide both the numerator and denominator by a first degree expression. Okay? So the result of that is going to be 1 in the numerator, and then when I distribute this radical x squared in here, I get the square root of 1 plus 4 over x squared. And now when I evaluate this limit, that approaches 0, and we understand why that is now. And we have 1 over the square root of 1, which is just 1. Okay. It's also good to get an idea for our answer again, because many times when we manipulate an equation, sometimes we lose some of the properties of our original expression here. So let's just think. If I put a huge number there, if I put a huge positive number there, that's going to be positive. And then if I put a huge positive number here, square it, add 4, take this, that's still going to be positive. So my answer is going to be positive to this, and it was. Let's take a look at the limit as x approaches negative infinity of that same expression. So take a look. I'm plugging in a huge negative number here. So think that's going to be negative. Negative number squared plus 4. This is going to be positive. So the result of this, and if I go through the work again, I'll just show you. We're going to, in doing this, we're going to lose some of the properties. But we know our answer is going to be negative here. So when I distribute that, I get 1. And when I distribute this, I get 1 plus 4 over square root of x squared. And that again goes to 0. 4 over x squared. No radical on that one. And again, we get 1 over the square root of 1. We lost that negative property of this. So we're going to make that adjustment in the end. Negative 1 is our limit. And you can see that happening here in on this graph. Here's 1. As x gets bigger and bigger and bigger, this function is moving up towards that 1. It's never going to quite get there, but it's approaching that. And over here, here's negative 1 right here. Notice this function is getting closer and closer and closer to that negative 1 as a function value, but never going to quite get there. Okay, so we see it conceptually, and we see it algebraically happening here. Think of your side. Last example. This is kind of an interesting one. Once again, right around a centered point, a lot of times it's the origin, it's doing some weird stuff. I know this isn't too crazy, but notice at its extremes, as it just keeps going to the right, it kind of levels off doing something. And look at this one. It's not leveling off, but it is. I can already tell the answer is going to be positive infinity here. It just keeps going up and up and up as it goes left. Okay, and this one, this answer is going to be, I have 0.2 here, so that's 1/5. It might be right around 1/5 or so. We'll see where the algebra leads us. All right, so let's evaluate this one first, and let's think about what the sign is going to be. Maybe that's going to help us, maybe not. So if I put, and by the way, if you think about this, the square root of 9x squared is 3x. So this is almost 3x, but it's adding an x value onto it. Okay, and then we're taking that away. So we'll see how that reacts as we work through the algebra here. If I put a positive infinity here, and then add, I know this has the biggest influence, but if I add a little bit more onto that, do you see that this is going to be bigger than this? A little bit, probably. So this is going to be a positive answer here. We're going to use our knowledge of conjugates, because infinity minus infinity, that's an indeterminate answer, so we're going to have to do some other things to this. And I'm going to multiply the conjugates together, let them do their thing, and I'm going to keep the denominator as is. So multiplying the conjugates, we know what happens in this multiplication, that this and this will cancel each other out. So we're only going to have 9x squared plus x minus 9x squared. And that results in, simplify that, we have x in the numerator, and in the denominator we have 9x squared plus x plus 3x. And now we're going to divide through by our highest degree in the denominator, which is first degree. Again, don't let this fool you. It's a square root of a squared quantity. So we're going to divide there, and we're going to divide there. Result, 1 over the square root of 9 plus 1 over x plus 3. That approaches 0, and we have 1 over the square root of 9 plus 3, which is 1/6. So as x moves to the right, that's 0.2, so we knew our answer was going to be right around 1/5, but there's a fraction a little less than 1/5, and that's 1/6. So that's what as we move towards positive infinity. And we had to work through the algebra there because infinity minus infinity is what we call indeterminate. So in the form we see it here, we cannot determine the answer. We have to work algebraically with it. Let's take a look at the limit as x approaches negative infinity. So if we do that, if we plug in a huge negative number, again, this is very little influence compared to this. All right, so we can ignore this. So as I plug in that negative infinity there and square it, that becomes positive. Okay, and multiplying it by 9, insignificant. So when we take the square root, we're going to have positive infinity minus 3 times negative infinity. We're plugging that one in. Another huge number. So this one was infinity minus infinity, which we said was indeterminate, which we have to work through the algebra a little more. This one, though, we have infinity plus infinity, which is infinity. So that's why this function, as it moves towards infinity, the y values are approaching 1/6. But as this function keeps moving left, these y values do not have a limit. They just keep approaching infinity. Up, up, up forever.